y equals arcsine of x. Here's the definition then of the arcsine function. As x varies from -1 to 1, the y values vary from minus pi over 2 to pi over 2. That's the definition there. So these are the values that y and x can take here. Okay, so let's take sines both sides then. So sine of y is equal to sine of the inverse sine. So one undoes the other, and we're just left with x. Differentiate then. Gives. So sine of something goes to cosine of something, multiplied by the something differentiated, y dashed. X differentiates to 1, so that tells us then that y dashed equals 1 over cosine y. Now we know from trig that cos squared y can be written as 1 minus sine squared. And we know that the sine y is x, so that's 1 minus x squared. Now the y values vary between minus pi over 2 and pi over 2, and that's when cos is always positive in this range, isn't it? So when we square root both sides now, we already know that we're going to need the positive square root, aren't we? So let's take the square root. We can discount the negative square root as a possibility now because of the restriction of the range of the y values, and we know cosine is positive. So we want the positive solution, and now we can piece it together. So y dash then is equal to 1 over cos y, which is 1 over the square root of 1 minus x squared.